So in this question, we are told that the refractive index of the block is 1.52. We're supposed to calculate the critical angle. So what is most important at this given point is to know the formula that connect critical angle and the refractive index. So we are going to look at that, and we shall see now refractive index and the critical angle are connected by the formula. Remember, this is one of the formula that you are not given the formula sheet. So we are going to, since we are finding the critical angle, we're going to say sine of the critical angle is equals to 1 over the refractive index. So this will mean that we can be able to say this is going to be sine of the critical angle is equivalent to 1 over 1.5. So which will mean that if we divide this, what are we going to get? If I divide 1 divided by 1.52 is going to be 25 of 38, and I like it when I give it as maybe I can just enclose this and I go direct to find the critical angle, and this becomes the sine inverse. This will be more accurate if you place it like that, 1.152 like that. So if you just press that into your calculator, can you check what you're gonna get here? Shift sign of whatever we have. I'm getting the critical angle to be, and write and comment down below what critical angle you are getting. That becomes actually 41.1. So this is what I'm getting here as our critical angle. Remember, critical angle is the angle of incidence when the angle of refraction is 90 degrees. So for total internal reflection to occur, the angle of incidence must be greater than the critical angle. So you have to remember that. Right? So we need to move to something else. Okay, let's see the next question. State what happens to the ray at the point L. Let's go back and see which point L are we talking about. So this ray is moving from a dense medium to less dense medium. Down here we have a less dense medium, and remember this is glass, so this is a dense medium at this point, and then down below here we have less dense. So when a ray of light is moving from a dense medium to a less dense medium, if the angle of incidence in this case is greater than the critical angle, then it means now total internal reflection is taking place. Actually, this is total internal reflection taking place at that given point. I would like you to write in the comment below what are the factors, what are the conditions for total internal reflection to take place. So at L, the ray undergoes total internal reflection. All right, you can share this live to your friends, invite them so that they can be able to benefit from the same. We need to move down to another question. This is a question about astrophysics, and this live is actually on the topics that were requested by some of you yesterday. So we are going to change the gear and look at astrophysics. Remember, astrophysics, you're gonna be tested only motion in the universe and part of astronomy in terms of stars, evolution of stars, but cosmology is usually tested in paper 2. So don't forget that cosmology is tested in paper 2, tested on motion in the universe and part of astronomy, right? So let's see the first, the question that here, space and all galaxies is called what? Space and all galaxies is called what? You can type in the comment below. You can comment down below. What do we call all galaxies? Basically, this is actually called the universe. So we can be able to write down here called the universe. A large collection of billion of stars is called. You can also type down below, how do we call a large collection, billion of stars? All right, this is a galaxy. Sun and the collection of planets is called what? This also you need to know how this is defined, and we're going to say this is the solar system. Solar system. Okay, so these are questions from astrophysics, so you need to understand those definition. And now we have an object orbiting the sun, and this object is actually the comet. And remember, the orbit of the comet is quite elliptical, is elongated compared to that of planets. So which point at this orbit is the comet moving fastest? It moves fastest where it's very, very close to the sun. That's where the gravitation of its strength is strongest, and that is actually point A. In this case, point A. And point C is the slowest, moves slowest. At A is fastest. So it will mean that at this given point, the star has, this comet has got the comet has the highest kinetic energy at that given point.